Okay, so a really long question. I wanted to put this one in here just so maybe you could see how you can get some of the marks even if you can't get all of them. The first couple of parts are not that difficult, you just got to really think about them. So, Anne has some sticks that are all of the same length. She arranged them in squares and has made the following 3 rows of patterns. She notices that 4 sticks are required to make the single square in the first row, 7 and then 10. It says find an expression in terms of n for the number of sticks required to make arrangement of n squares in the nth row. So she's got a sequence that's 4, 7, 10. Now, you can do this by just doing the nth term. You know the difference is 3. To find the first term, you are adding 1 to get to 4. So your nth term for this sequence is 3n plus 1. You may here as well have written down that a was 4 the first term, and the common difference is 3. You can form an arithmetic sequence in terms of n for this, in terms of, well, we've got the nth term is a plus n minus 1 d. If you put a and d into this, then you've got 4 plus n minus 1 times 3. And if you multiply all this out, this does equal 3n plus 1. So that's why there's 3 marks there, but you would get 3 marks for getting to this rule, and then the other 2 marks are for putting a and d as the first term and the common difference. But those 3 marks can be gained by noticing what a and d are in the following parts of the question, because obviously you don't need to use a and d to work out the nth term. Part B is the sum formula. It's the total again, which means sum. We've got a and d, so at this point if you put a was 4 and d was 3 in part B, you would get the marks from the first part of the question. So all we're going to do is we want the first 10 rows, so we've got sum of the first 10. N over 2 is going to be 10 over 2 times by 2a, well we know a is 4, so it's 8, plus n minus 1, so 9 times the common difference, which is 3. And if we multiply all of that out, then we get 5 times 8 plus 27, which is 35, and 5 times 35 is 175. So the sum of those first 10 rows is 175. Now part C and D, I've got K involved, and I know that you don't like K. Let's see what it says. So Anne started with 1,756. Given that Anne continues the pattern to complete K rows, but does not have sufficient sticks to complete the next row, the K plus 1th row, show that K satisfies this inequality here. So we're going to use our sum rule. We know that the sum of the K terms has got to be less than 1,750, because I can't go above that. Okay, but it actually can be less than or equal to 1,750, but we'll just say it's less than for now. The sum formula is your n over 2 times 2a plus n minus 1d. Now, the n is what we're trying to figure out, because we're trying to figure out how many the sum is that gives us less than 1,750. So we're going to put k in as n. We know that the a was 4, so we've got that as 2a is 8. And then obviously n, put k in again, and we know that the common difference was 3. Okay, and we know that we want all of that, because we've just said it here, we want all of this to be less than 1,750. So we're actually just going to put less than 1,750 there. Can't quite fit it on myself. Put it in a line for you. Then you can figure out what all this is expanded. So k over 2 is equal to 8 plus 3k minus 3. When you multiply that bracket out, less than 1,750. Inside here, you've got 5 plus 3k. If you add together your 8 and your minus 3, and k over 2, less than 1,750. So this is what we've ended up with so far. So what we're going to do is we're just going to keep rearranging this so that we can hopefully solve what k is. I'm going to times by 2 to get rid of that fraction there. So then I end up with k bracket 5 plus 3k is less than 3,500. If I multiply out now the k bracket 5 plus 3k, then I get 5k plus 3k squared is less than 3,500. I hope some of you are now seeing what this has turned into. If we gather it all on one side and just put it in order, we've actually got a quadratic. Now, thankfully, they've given you in the question the answer, which was 3k minus 100 bracket k plus 35 less than 0. Just check by expanding this, in whichever method, the smiley face method or the grid method, that does equal 3k squared plus 5k minus 3,500. But it does, so you've shown that actually by forming that sum formula, you've got to that inequality there. Finally, part D says find k. Well, once you've got this inequality, then either 3k minus 100 is less than 0 or k plus 35 is less than 0. There's two solutions to this, isn't there? There's 3k is less than 100, so k has to be less than 100 divided by 3, which is 33.3 recurring, so k has to equal, the highest k can be for it to be less than 0 is 33. If we went with this one over here, then k would be less than minus 35. Now, remember k is our number of terms, so it cannot be a negative, so that one does not exist. So the only one that does exist is 33. And therefore, because remember we're finding the greatest number of k, though it was 33.3, we're going to pick the nearest whole number because that's the number of terms, so k is 33.